Hello again, YouTubers. Today I wanted to talk to you about my Logic Probe project. I've called it Logic Probe version 1, basically because it's a very extremely simplistic implementation of a Logic Probe. And in this tutorial I'll be helping you understand first of all, what a logic level is, and we'll be showing you a circuit on how to test for logic levels. First of all, let me explain what is a logic probe. So a logic probe is a device which detects logic levels. Logic levels are discrete voltage levels that represent ones and zeros in a binary circuit. So what it will do, the probe will indicate if there is a 1 or a 0 present in a circuit. And this allows a designer or hobbyist to quickly troubleshoot a circuit to see if logic levels are present and what they are. You can usually find these as off-the-shelf devices, which are usually small handheld devices, such as the one depicted in the bottom right. And what they allow you to do is they allow you to probe any point in a circuit using a sharp probe, which you can test any pin on any microchip or pad with in any point in the circuit. And the way they operate is they connect to the power supply of your circuit. So it's essentially a device that is powered by the circuit that you are reading, and it will indicate with an LED on the device. You can see at the bottom right there's a red triangle and a green triangle, which indicates either a high state or a low state. So let me go into a little bit about what a logic level is. So you find two standard types of logic levels, one being TTL, which is short for transistor to transistor level, and you usually find those in 5-volt type circuits. And then you get the CMOS type, which are devices that run on a lower voltage, which you usually find in lower power and more modern and more compact devices. So both of these standards, they define two states in a digital circuit, which can either be on and off. And these two states, they represent the binary numbers of a 1 or a 0. So an on state would represent a 1, and an off state would represent a 0. And conversely, in a voltage driven circuit, you would find that a 1 in a TTL circuit would be 5 volts, and a 0 would be 0 volts or ground. And in a CMOS circuit, the 1 would actually be represented by about 3.3 volts. So those are the critical differences between the two standard types of logic levels. And in the diagram below, it depicts the standard also defines acceptable TTL gate input signal levels. So these would be input signals to a TTL device, and what it defines is that any voltage between 2 and 5 volts will be represented as a 1, and any voltage below 0.8 volts and 0 volts would be represented as a 0. So these are the thresholds levels within the inputs of a TTL device. And then on the right we show what the standard defines as what the output signal levels should be in a TTL device. So you can see the output is higher, is defined to be higher as what the minimum input voltage should be for a high state. So that means it sort of tries to correct the signal as much as possible. So if, for example, your circuit experiences voltage drops, it still has quite a large threshold or window level that allows the circuit to still function correctly and also tolerate voltage drops. So what the output level defines is it forces the voltage to be much more within the minimum input levels of other devices. So as more and more devices or TTL devices are connected, they tend to self-correct if there's any sort of voltage variations in the circuit. So let's have a look at the CMOS logic levels. So you'll find they get used in a lot of modern low power and small footprint devices. The standard has been around for a couple of decades now, and it's becoming more and more popular as you find that a lot of devices are moving towards lower power and more portable and much smaller microchips and devices than you find previously. And one nice thing about it is that the CMOS logic levels are able to interface with 5 volts TTL devices. So they kind of have a back compatibility feature built in, which is really great, and it really helps, makes it easier for designers to use modern devices with older devices. However, there is a caveat to this, in that the TTL devices are not forward compatible with CMOS devices. Well, due to the nature that TTL runs at 5 volts, if you output the 5 volts to a CMOS device, there is a chance that you can damage the CMOS device as the voltage will be out of spec and too high, and they're not designed to accept such high voltages. Luckily, there is a way around this. You find a lot of modules available online. The TTL or TTL to CMOS logic level converters, which are quite cheaply available, and you can even build them out of a few parts yourself. So that's always something to keep in mind, is that it's not always a train smash if you need to output from TTL to CMOS devices. And on the right, I've just got a representation of what the logic levels are for the CMOS. That you can see it's a maximum of 3.3 volts, and the VIH represents the minimum input voltage for a high level, so input high, and the CMOS device will output a minimum high output level of 2.4 volts. So similarly to TTL devices, they tend to auto correct themselves by outputting voltages that are well within the minimum inputs of other CMOS devices. Alright, so in order to measure logic levels, I found a very easy to build circuit online, and I've got it here in the schematic, which I actually have built and tested myself, and it's very quick and easy to build, and quite effective. And essentially just a few things to note here are the V plus and the ground pins need to be directly connected to the circuit that you're testing. So if it's a CMOS circuit or a TTL circuit, it doesn't matter, it will be compatible with both. And the probe can be connected to any point in the circuit, which lets you determine based on which LED is lit up, if it's either a high level or a low level that's being probed. So the resistor divider network here essentially inputs a certain fraction of the probed voltage into the op amps. So you'll find the red LED, which is the high level indicator, will light up at 11/20ths of the supply voltage. So that equates to roughly 2.75 volts in a TTL circuit or 1.8 volts in a CMOS circuit. So those are sort of well within the minimum high levels of a CMOS circuit and a TTL circuit. And then the green LED will light up, will represent the low signal, and will be lit at 9/20ths of the probed voltage or less. So it'll be anywhere between 2.25 volts for TTL or less, or for CMOS it will be 1.485 volts or less. So in this slide I've got the circuit connected to my breadboard, and basically showing you how fairly simply it is to wire it up. And I've got the V plus and V ground wires hooked up to the breadboard, and I've got them moving across to the bottom power rail. And you can see here how the resistor divider network is connected. And yeah, here I've got the LEDs. I think the green one is actually lit at the moment, but let's see how this would work in a circuit. So here in this photo I've got the logic probe connected to my Arduino on a breadboard, and this Arduino is running the Blink program, which is one of the first examples that I shipped with the Arduino IDE that you can load, and that will run quite easily on any Arduino Uno or Arduino breadboard projects. So I've got the probe wire connected to the output pin that lights up the LED, and now you can see that there's no LED lit up at the Arduino, and the logic probe is lighting up the green LED, which means it's a low level. The TTL level is low, and then you can see that the power of the logic probe is hooked directly into the Arduino power supply. So they run at the same voltage. So if this were a TTL or a CMOS type circuit, it would work just as well, because the resistor dividers will will have a threshold within fractions of the circuit voltage that you're using. So in the next photo, I've got the LED of the Arduino. It's lit up, which means that pin is sending out a high signal. And you'll see on the logic probe, it's lighting up the red LED, which is the high logic high indicator. And nothing else has changed on the circuit. I've got everything hooked up exactly the same as the previous circuit, except the program, the Blink program has been running, and as that LED is lit, that pin is set to high, which obviously shows immediately on the logic probe. So yeah, that's it. That's been a very short video for today, and I hope I've given you a better understanding of logic levels. I've shown you a low-cost, easy-to-build logic probe, and nice thing about it is that it's a very simple and small circuit to build. And I just wanted to credit Spark Fun for the logic level images, and I just wanted to underline this, that all the content that I've been showing is licensed by the Creative Commons share by attribution license. You can check out the license in this link or in the description of the video. And yeah, so if you find my presentation useful and you'd like to share it, please don't forget to mention me in the credits. And yeah, if you enjoyed this video, give it a big thumbs up, leave any comments, and subscribe. Thanks for watching. Cheers.